Let's first take a look at where electricity comes from. Electricity is not something that actually exists. You can't put it in a bucket like water. Electricity is a reaction. In the course of its reaction, it's causing other reactions, like your lights coming on. To understand this, you first need to understand atoms. I know, boring. But understanding the atom is important to understanding where volts and amps come from. Atoms are the building block of all matter. The makeup of an atom will be different depending on what that matter is. To keep it simple, our atoms will contain one neutron, one proton, and one electron. An atom contains protons, electrons, and neutrons. Neutron being neutral, the proton being positively charged, and the electron being negatively charged. The electron is where the term electricity is derived. In materials like wood, glass, rubber, and many other surfaces, in the atomic structure of the atom, the electrons in the outer shell of that atom are permanent. In materials like metals, the electron in the outer shell, the free electron, can move or be moved, but always wants to retain its original atomic makeup, its neutral state or magnetic balance. So if one electron gets pushed into another atom, one electron must leave. If one electron leaves an atom, it will try to attract another electron. Keep in mind that only the negatively charged electrons can move. This is how you get current flow. I know it seems too simple. I am describing one electron in one small unseen atom. Keep in mind that there are 43 quintillion atoms in 1 grain of sand. 1 amp is 6.28 times 10 to the 18th power electrons per second. You don't need to remember that. Just remember, when we are talking electrical flow, current, and amperage, we are talking a lot of atoms moving at once. Electrons cannot flow freely through the air. They must first have a conductive path to try to follow to attain balance. The conductive path must be through something that has electrons that can move freely. Metals have those electrons. Copper is the most commonly used metal, though many others have better or worse conductivity. I will touch on this a little later when we talk about wiring. What makes an electron want to move? We said electrons are basically held together by magnetism. In magnets, we have a north pole and a south pole. Electrons want to maintain their magnetic balance. They are either repelled from or attracted to other atoms, just as magnets, north pole and south pole, are attracted to each other, but north pole repels another north pole. They want to remain magnetically balanced. Electrons can become magnetically out of balance by introducing something to make them start moving, much like a pump will pump water. And while those electrons are moving, they carry with them the magnetic imbalance, creating a magnetic field around whatever conduit they are traveling in. It's this increased flow and magnetic field that gives you a difference of potential from one point to another. Just to give you another example, you will hear people use water to explain this process because it's easy to visualize. Electrons or electricity will flow until it achieves balance, much like water. Water will flow to where it's not until it is balanced. Once the other side has reached the same level, no more water will flow unless you give it a push with a pump, which is similar to what happens when we use electrolytes to cause a chemical reaction or a magnet to create a magnetic field. We will discuss this magnetic field when we get to alternating current. If you have ever received a static shock, that is a buildup of electrons in your body created by friction, leaving your body to create balance or equalize the difference of potential. You have excess electrons in your body leaving at a high rate. When we measure voltage, we're measuring the potential difference from one point to another. If we look at the two glasses again, the lack of flow does not equal the lack of water. If we measure the difference from one point to the other, it's zero difference. This is important to keep in mind when measuring electrical circuits. Once we have a difference of potential, then current can start to flow. It's trying to regain its original balance.